In this project, we want to detect and predict bradycardia. To doing this, we are using ECG sensor which detect the heart beats inside the human body. At first, we read this file which created by this sensor with the special library edread for which read EDF files. And then we are using the filter to remove the noises and clean the data and prepare it for the next section. After that, we have the RPIC detection part. In RPIC detection, because if we apply RPIC detection over whole the day data which we collected, there will be some problems. So we divide it in small parts and then we concatenate this RPICs. So we divide it in 500,000 parts, and then we run the RPICs detection which provided by lab, and then we detect the peaks inside the signal that we have. In the next part, we are calculating the heart rate using the formula which provided in our paper. So by using that, for each beat, we are calculating the heart rate. In the next section, we are detecting the bradycardia using the threshold that we have applied for the peak. And then finally, we are here we are detecting the bradycardia, and then we are finally we plot all the information. At the end, we also save the heartbeat as a CSV file for using in the Android section, which we want to detect bradycardia and also predict it in our data. So if I run this application, this would start reading the file, and then this is the filter, and then we have the beat detections. This is the beats detected by our algorithm. At this green part are those areas that we have bradycardia. If I zoom inside the data, this is a filter and clean signal. I need to zoom more to make it clear. Here, it shows each of these are 1 beats of our heart. So we are cleaning it, and then using the RPIC, we are detecting this peak. And using the distance between 2 peaks, we are calculating the heartbeat rate. Thanks. This is the part for the MATLAB part. Now that our method created the heartbeat.csv file, we use it in our Java. In this part, I want to describe the Java part. In the Java application, we are doing 2 different actions. The first action is reading the file and detecting the bradycardia. For doing that, so we have 2 buttons in the application, which by clicking on these buttons, you can decide to detect and then predict. In detection task, at first, when the person clicks on detection, we are starting reading the file. So here we are starting reading the files that contains the heartbeat rate. And then when we read the data, we use a threshold method which we set it to 65 to detect whether a bradycardia happens or not. After this detection happens, in the next section, we plot all the information on the graph. So we plot the heart rate, and using some red marker, we show that where we have a bradycardia. In the next section, we have a prediction task. For the prediction task, we are using the same data, so we don't need to load it again. Here, at first, we start reading data one by one, and we check the variance. If the variance change a lot, more than our threshold, we predict that in that area we would have there is a high possibility that we have in the next interval a bradycardia. So we detect that, and we plot those things inside the application. In the next section, when we are done with the prediction, we also calculate the true positives, false positives, and false negative to a further investigation. So here now I want to run the application. If I compile it, yeah, so okay, so this is our application. When the user click on detect, he or she can select a file that they want to use. This is the heartbeat.csv that we created in our MATLAB application. When I click on it, so the application would show me the heart rate. Also, it writes that in this point we have a bradycardia, but also the user can move this graph, and then it would be able to find some points that we have bradycardia. It's a sample point. The user it detects it's lower than 65, so it detects as bradycardia. Also, we are showing the execution time here, which is 430 milliseconds for the detection part, which asks in the project. By clicking on predict, we would have the next graph. In this graph, we have the variance changes inside for each beat, heartbeat. Using our algorithm, we detect these points as the possible position that the bradycardia happens. Our true positive is 9 points, and our false positive is 107 points. And the false negative is 107, false positive is 46 points. These numbers, if we compare it with 47,000 points, it's very low, and we are detecting we are just missing 46 points. And also, because these data are coming from a healthy person, a normal person, this data is okay because we don't have this variance. But if we have data from a person which has a heart problem, our algorithm can be better. We also showing the detections, and this is the prediction intervals, and you can use these intervals to see how our algorithm perform. Thank you. If you have any other question, you can read our paper, which was submitted by this project. Thank you so much.